now straight away let us go to the lab and we will going to build this topology. So here I am in CML portal. I will going to create a new project. So I hope you are already aware of the Cisco Modeling Labs. I have already added a separate section to get you familiar with CMLs. Let me name it as NAT LAB. So aim is to build this topology. So now let's start. I have already explained this topology to you. So we will going to develop the intranet of XYZ Corporation first, right? And as I said, every end devices in this topology, I'm going to use a CSR V1000 router, which you can see here. So to start with, let me drag CSR V1000 router, which is our FTP server, followed by our web server WS1. Now in Cisco CML Labs you don't have hubs, so need not worry. So both FTP server and web server need to be connected to the switch. For that you can use this unmanaged switch here. Now since you don't have a hubs, so you can simply connect these end hosts to the switch without using hub. We really do not lose anything in doing so. So I will add a link from gig 0x0 to the switch. Okay, so the name of the ports can vary with respect to the diagram. In the diagram we have gig 0x0 here. But here, because we are using CSR 1000V router, whereas in the diagram, the device that I have used is Cisco 7200. So the port name may not exactly match. Here it is gig 0x0, here it is gig 1. So it really do not matter, you just connect the devices. And similarly, you connect the other device. Right? So how easy? This is the intranet of XYZ Corporation. You can also draw a rectangle and encapsulate this portion of a diagram within a rectangle. Now followed by this, we have to add this Cisco ASA firewall. So you can see on the right hand side, this is Cisco ASA firewall. You can simply drag it again. Add link, and from Cisco ASA firewall you can take gig 0x1 interface and connect it with the switch. Now you can see that in our topology diagram we have ISP router here. So we are done with the XYZ Corporation intranet. We are done with Cisco ASA firewall. Now we will draw this gray diagram which represents internet. So we will going to drag a router. Router is nothing but again it is Cisco CSR V1000 router, and then you can add link 0x0 to gig Ethernet 1. Alright, so you can see that the link has been added. Now you have to take 3 host machines and add it to the topology. So again, as I said, that all our host machines are nothing but they are CSR 1000V routers. Though in real practice you should use different types of machines in order to represent end host. So since there are 3 public hosts, so I will drag 3 copies of Cisco CSR V1000 router. Right, so we are done with the internet part of this topology construction. You can put text on your diagrams. So let us write all the IP addresses against each interface, as you can see in this screenshot. So if the IP address on one side of the link is 128.0.0.1 for example, then it is quite understood that the IP address on the other side, I will always take it as 128.0.0.2, right? So we can avoid writing IP address on both the sides of the link for the clarity. So here on interface gigabit Ethernet 2 of ISP router, there is no need to write an IP address. So guys, you can see that with this, our construction of the topology diagram is complete. Now the next thing that we will going to do is to do the basic configuration, that is the configuration of IP addresses on the interfaces and what are the necessary routes that you need to install in order to make this lab ready for network address translation configuration. So now let's do the base configuration on this lab. The base configuration means the configuration that you need before you can go for network address translation. Now as a next step, now I will going to start this lab and wait for the devices to boot up. So guys, now when it comes to configuration, you can see that on the blog, I have also specified the base configuration for each device in the lab. For example, this is the base configuration for Cisco ASA firewall. This is the base configuration for ISP router and so on. So we have to do exactly these configuration on the topology devices. So let's go ahead and do that. So to begin with, let us go to the console of Cisco ASA firewall. You can write any password. I am writing Cisco. Host name you can give ASA. Now interface gig 0x1, no shut, IP address 10.0.1, and you have to specify the mask value in ABCD format. Now gigabit 0x1 interface of Cisco ASA firewall is an inside interface. So for that you need to use nameif configuration, nameif inside. Alright. Don't just give any other random name, just use the proper name inside. Similarly, we will configure the other interface. Assign them IP address. And the name of this interface is nameif outside. And in addition to this, we have to do one more configuration. As you can see, we have to do this configuration as well. Now this configuration need not be explained, you just do this configuration. Those who understand Cisco ASA firewall configuration may understand this configuration, otherwise for you there is no need. and then you have to install a route. So this is the default route that you are installing in Cisco ASA firewall. This default route means that if firewall has to forward an IP packet, it will forward the IP packet blindly towards Internet Service Provider, that is ISP, as long as the packet is destined for some remote machine IP address. So now you can save the configuration, write memory. And with this we are done with the configuration of Cisco ASA firewall. Similarly, ISP configuration is very easy. All you have to do is to configure the IP addresses on the interface. So let's straight away begin that. Go to the console of CSR ISP router. Let's name the device as ISP. Now I'm configuring the interface Ethernet 2. So we can verify using command show IP interface brief, and it will show the IP addresses that we have configured over all the 4 interfaces of ISP router. So there is no other configuration that needs to be done on ISP router. And now we will do the configuration on AND host machines. So in total we have 1, 2, 3, 4, 5 AND host machines. So we will do the configuration on each of them. So starting with the FTP server. And after configuring an IP address, you have to install one route on the FTP server, which is a default route, of course. And this default route simply says that if FTP server has to push any packet, it will do so towards the next hop 10001, right? Because we are installing the default route. Now you can save the configuration. And we are done. Similarly, we will configure web server 1. And install the default route. So here we are done with configuration of both the AND host machines which are present in XYZ Corporation. Now we will going to configure the AND host which are present on the internet. So I have renamed it as public host 1. Now here you have to install the default route as well. So this default route simply says that if this AND host has to forward the packet, it would forward it towards the next hop 128.0.0.2, which is nothing but Internet Service Provider router. Then come to the public host H2. And you have to install the default route towards gateway 129.0.0.2. I hope you are well familiar with general routing concepts. And finally the last machine, which is web server 2. Just add a default route. And that's it. So our base configuration is ready. And we are done with the configuration of our entire lab. Now, in order to test, you should be able to ping from each public host to any other public host. So from web server WS2, let me ping if I am able to ping public host H2 or not, which is 129.0.0.1. And I'm able to ping. Similarly, let me ping public host H1, which is 128.0.0.1, and I'm able to ping. Similarly, internal host can ping each other, and you can verify that. So with this, our lab is pretty much ready for network address translation now. We need not do any configuration on these unmanaged switches, that is the switch that we have used here. It is just doing its job properly without any configuration. So guys, what I will going to do now is that I will going to export this lab into a file so that you can come back later again into the lab and resume your work from the same point where you had left by importing the file that you had exported. So for that, first of all, you need to save the configuration of each device that you can see in this lab. So for that, you just click on that particular node, go to edit config, and just click on fetch from the device. So you have to do this exercise for all the nodes in the topology. You need not do this for unmanaged switch, but for all other devices. And we are done. Now the next step is to download the lab. And you can see that here a file is created which is called natlab.yaml file. This file you can save it safely on your hard drive. This file will be needed in order to resume your lab. So guys, that's it. I hope you are able to follow how to construct the lab and how to do the base configuration. Now from the next lecture video, we will resume with our static NAT configuration and discuss how it works.